Hello, everybody. I hope you're doing well, whether it's early in the morning, lunchtime, or late at night, depending on where you're watching this. So I'm going to show you a few examples through 10.7. This is basically systems. So back in chapter 3, if you recall, we talked about elimination, substitution, and graphing. And it was pretty much with quadratics, with lines. Those are the two kind of main ones that we talked about. But now we're going to throw that in with circles. So this would have been your warm-up in class. I would have shown you all three of these first. Okay, so you'll see that part A there, that was a circle. At the center is -2, -5. The radius is 6. Part B, there's a quadratic that is shifted to the left 2 and down 5. And then C is a line where if you converted that into slope-intercept form, its slope would be 3/2. And the y-intercept will be -4. So I'd have you guys graph that, and I'll go ahead and show you what that looks like. So it's like that. So if I asked you, how many solutions would the system have if you just looked at A and B? So if I look at just the green and the red, that would be 2, because the quadratic touches that circle 2 times. What if I asked you about A and C? So if I'm talking the green, the blue, that would also be 2 because it touches twice. What if I said B and C, so red and blue? Those never touch, so that would be 0 solutions, or, in the past we've done no real solution, and then we learned I, the complex number. And if I asked you for all 3, you would say 0 because there's no place where all 3 of those touch. So we're only going to focus on 2 at a time. Don't worry about worrying about Z. We're not going to do that with circles. So there's 4 examples that I'll show you here. I don't want you to see the answer here, so I'm sorry. One thing I want to show you. For each situation, I want you guys to think about how many points of intersections could exist and list all of those. So think about 2 lines and then think about 2 circles. So how many, and we did the 2-line one already, but think how can 2 lines intersect? They can crisscross and touch once. They can be the exact same line and touch infinitely many times, or they could never touch and they would be parallel and either be no solution. And then think about 2 circles. So like a Venn diagram you've done before, but I'll just go ahead and show them to you. You can choose to sketch these if you wish, but mainly just keeping these ideas in your mind is what's most important. So they could touch 0 times, exactly 1 time, and twice, and then they could be the exact same equation and touch everywhere. The next one is 2 parabolas and then a circle and a line. So 2 parabolas, we did do that back in the fall in chapter 3, but they could be one vertical, one upside down. They could touch once, they could touch twice, never, the same quadratic, those different things. And I'll show you that in a second. And then think about a circle and a line, which we just did a second ago in that little warm-up. I'll go ahead and show you those little sketches here. So 2 parabolas have 4 scenarios. The circle and the line have exactly 3. Now, you actually did do this situation last year in geometry, which we're going to touch that actually more later this week when we get to section 10.5. What you would have learned in geometry last year is that this is actually called a secant line. So that's a secant when it touches a circle twice. If it was a line segment where it touches just the circle edges, it would be called a chord. Where it touches just once, that was actually called a tangent line, which again, we're going to use that in a few days. And then 0 if it just doesn't ever touch. And then I'll show you the other ones just for funsies here. So a parabola and a line, they can touch in those 3 different situations. Even if you tilt the line, it's going to have the same, I just drew it that way, but it's 0 once or twice. The circle and the parabola is probably the most unique. It's got 5. So kind of keep all those ideas in your head. You don't have to memorize all of those, but it will help you kind of predict what the solution is going to look like. So there's 4 examples. So let me first just show you what that could look like. So basically what's going to happen is you're going to be given 2 things. It could be 2 lines, 2 circles, a quadratic, whatever. In this case, so I'm going to give you a line with a circle. You're essentially doing substitution, okay? Algebraically, we want to know where are they intersecting? Where do they satisfy each other? So first thing that I would recommend is graphing it, just so you have a visual to kind of go with it, like to see if your algebra is matching up with what's supposed to happen. So, if you draw your circle and your line and they never touch, then you should know that you're going to get something that's not going to work out. If it touches once, and you should get, X or Y equaling an actual number. Now, just like before in chapter 3, it doesn't really matter which variables you solve for, but you want to work with what's easiest. So if you look at this first equation, is it going to be easier to solve for X or solve for Y? I'm hoping you're saying X. Okay, solve for X there. And again, solving for Y isn't wrong. It's just you're going to create a bunch of fractions. So solving for X gets us that. And you're going to literally plug that in, follow that arrow there, plug it into X. And then you're essentially going to FOIL, combine some like terms, and then see what happens. So I plug it in there. Then you FOIL, combine like terms. Now this one actually is not bad. It's a quadratic that you don't actually factor the big kind of way that you guys always think about. Instead of it's just a greatest common factoring problem. So take out a 2 and a y. It looks like that. So you're going to get 2 values for y here. You should be getting 0 for that first piece and then -9/5. Okay. Once you have that, essentially, since you've got 2 y values, that means your circle and your line, they better be touching twice if you were to graph it. So you're going to plug the y values back in to this original one up here. Now, if you're worried you did that wrong, you could go back over here, but it doesn't really matter. So plug 0 in here, -9/5 in, just like you did over here. Solve for x there, you're going to get 3, and then you'll get that decimal or that fraction there. So you better make sure those are 2 separate coordinates. So 3, 0, -12/5 and -9/5. So it's got 2 real solutions. All right, and this one, I'm gonna cover it because the answer's over here. So I'll show you this whole thing first, okay? You can already see it there at the bottom. I'll just show you the whole thing. So you can pause this and read through it how you want. But this first one here, so that's gonna be a circle, okay? I just kind of saw, I have the y squared isolated, but if you move the x squared over, it's gonna be a circle with a center point of the origin, and the radius is 5. And this guy right here, it is a line, okay? It looks like that. Your y-intercept is 1, your slope is 1. So you could have solved this for x or for y. Again, y is one less step. So I solved that for y. I plug that in up here, FOIL, combine like terms. Now at this step, you'll see hopefully that those are all even. You want to get rid of all that. So divide everything by 2. You get this nice quadratic here, factors nicely, and we're going to get, again, 2 real solutions. Doesn't always happen. And just for fun, I did show you guys over here, if you wanted to complete this square for extra practice, like what that could look like, you're going to get 2 nice whole numbers. So just keep it in mind. The next thing I want to really quickly show you is how to do this on the calculator, because I know in class normally I get a lot of questions about this. So you'll see right here, this is almost solved for y, okay? We talked in the last video about you can draw the circle, but you can't actually graph it. If you do want to graph it, you can. It's just you have to show it in 2 separate equations. So like if I were to ask you to isolate y here, you'd have to square root both sides. Well, that's going to create a positive and negative. And no, you cannot just make it like 5 minus x. That's not a thing. You can't do that. So I went ahead and graphed it on my calculator to show you what this looks like. So I already graphed, let me get out of that. Okay. The first one here is the x plus 1, so that's my line. This is the positive, so it's the positive version of the square root. This is the negative. There is no positive negative button. You're going to have to write them both separately. The TI does not want to graph circles. It doesn't like it because it basically conflicts with that law of it being a function, because you can't have it be a function there. So that's why you have to put them in separately. So if you do that, you're going to see something that looks like that. Now, some of your newer ones may actually complete it all the way, but these older ones, it is going to look like there's a little bit of a gap. There is not, okay? It does keep going, but it's just, again, the TI is so pixelated, it almost looks like a line, which it doesn't want to do that. So the solutions are nice whole numbers are here, which you can already see, but -4, -3, 3, +4. And if you have time at the end, you should always plug these both in. So plug this in here and here, plug this in here and here, and make sure they work. I'll just go ahead and show you the entire next one so you guys can see it, because it's not always nice like that previous one. So this one is again a quadratic with a circle. So it's a little different now. Okay. So what I did was this is already solved for x squared. You know, no one ever said you had to solve for x. You just have to solve for a variable that already is there, so to speak. So notice that we already have an x squared here. Well, that equals x squared. So that's fair game to plug that into here. So we get this nice quadratic here, and you're going to already get y being two nice whole numbers here. Now, when you plug it in, it's going to be a little goofier. Because here's the thing, there's actually way more solutions than that. So you'll see that in 1 second here. So plug in -3 here, plug in +1 here, and you're going to solve. Turns out you're going to actually have 4 solutions. There are actually 4. Now, 2 of them are imaginary, and then 2 of them are real. But if you want to pause the video or you want to, that's totally fine. So you can see this again. But technically there are 4, okay? Because this one gets you the positive negative I root 6. This one gets you positive negative root 2. So if you were to just graph it on a calculator, you would only see these 2. But technically, those are also imaginary solutions, okay? So just kind of keep it in mind. For this particular unit, we're going to care way more about the real solutions. But just want to make sure we covered that. So there's 2 real ones. And the last one, I'll just show it to you. Okay. So a circle here and then a line. So I solved this one for x, plug it in, and again, it's not too messy. So you can pause that and write these down as you wish, but use these to help you with the assignment. And let me know if you guys have any questions.